Dear students, greetings. Today we will study chapter 13 NCERT CBSE class 12th. The chapter name is Nuclei. Nuclei is nothing but nucleus. The radius of nucleus will be 10 to the power minus 4 time of the radius of the atom. The volume of the nuclei will be, we can give it by 4 by 3 pi r cube. It could be a sphere that will come to 10 to the power minus 12 times of volume of atom. The mass of the atom, nucleus, nucleons will be given by a unit called atomic mass unit. Atomic mass unit, formerly known as AMU. The sign is U. 1 AMU will be equal to 1/12 of the mass of 1 carbon 12. That will be equal to 1.992647 into 10 to the power minus 26 kilogram divided by 12. So 1 AMU is coming as 1.660539 into 10 to the power minus 27 kg. The mass of different nucleons will be measured by the mass spectrometer. Further in this chapter, there's few important points which we need to know. That is, let's say first one is isotopes. What is isotope? Isotope is the different type of atoms of the same element which exhibit the same chemical properties but differing in mass. Okay, yes, isotopes are different types of atoms of the same element which exhibit the same chemical properties but differing in mass. The best example or the common example which we can take is hydrogen. It is isotope. The first one is itself is hydrogen, or will be known as, my apologies, the first isotope will be known as 1H1. 1H1, that is called hydrogen or proton. Second is 1H2, that is deuterium. First one is basic hydrogen. Okay. The third is 1H3, that is known as tritium. The mass of deuterium is 2.0141 AMU. Tritium is 3.0160 U. So there is a difference in mass, but they all three exhibit the same chemical properties. Only mass is different. And these are the atoms of different type of the same element, hydrogen. Now we need to know few other basic things. Among these would be, first is atomic number. Atomic number expressed by Z, that is nothing but number of proton present in an atom or a molecule. My apologies, number of protons present in an atom, that is known as atomic number. Neutron number expressed as capital N. Neutron number is number of neutron present in atom. The third one is mass number. We denote it as A. The mass number is Z plus N. That means the mass number is Z plus N. That means total number of protons and neutrons. Over here, the protons and neutrons will be called as nucleons. We express an element as X, Z, E, where Z is the atomic number and A is the mass number, and X is a symbolic representation of that atom or that element. Next important thing is the isobar. What is isobars? All nuclei with same mass number A are called isobars. All nuclides with same mass number A, let's say, are called isobar. Example which we can take over here is nuclides 1H3 and 2He3. These two are isobars, that is tritium and helium. Now the next thing is the size of nucleus. By performing a scattering experiment in which the fast electrons we have used in place of gamma or alpha particles, and we have found that the nucleus of mass number A will has a radius of r, that will be equal to r naught A raised to the power 1 by 3. This is mass number, and r naught will be equal to 1.2 into 10 to the power minus 15. This is a experimental result, this formula. Okay, the volume of nucleus will be proportional to r cube, so that it will be proportional to A by using the formula. Let's say it is 1. Okay, the density of nucleus is a constant quantity. It will be independent of anything, independent of A, and it is constant for all nuclei. That will come to approx 2.3 into 10 to the power 17 kilogram per meter cube. This is a huge density. The reason is the nucleus is so dense because most part of an atom is empty, and ordinary matter consists of atoms will have a large amount of empty space. That means all the mass is concentrated in a very small area. We'll do a question. Let's say, for example, we have been given a mass of iron Fe nucleus, that is 55.85 AMU, and A is 56 for the same. So we have to calculate the nuclear density. So what is the nuclear density? That would be mass upon volume. That will come as 2.29 into 10 to the power 17 kg per meter. Next we have mass energy Einstein equivalence. Einstein mass energy equivalence. This will be given by E is equal to mc square. It is a relationship between mass of the matter and energy produced when that mass will be converted into a given energy. So this is a relationship between a matter and the energy produced by the same matter. For example, if mass is 1 gram for a said matter, for a given matter, then the energy will come as 10 to the power minus 3 kg into 3 into 10 to the power 8, that is in square meter per second. That is also in square because it's the velocity of light, and we'll get energy equal to 9 into 10 to the power 13 joule. In next class we will study the mass defect, binding energy, and nuclear binding energy, and radioactivity. Thank you very much.